So today we're going to be solving equations with what we call nested radicals. And this is an intermediate step between solving equations with full-on radicals. And the idea is that we're going to isolate the radical first, so that the radical is the only thing left on that side of the equation. Then once it's been removed, we're going to isolate what's left inside. So it's a two-part process. Get the radical by itself and remove it, and then simplify what's left. And one of the big things that I think we need to cover before we even begin this lesson is what it means to write a radical and what's included in the radical. Now, with computer script, the radical tends to have a straight line and it stops being written once it's past the final thing that's being rooted. So both the 4 and the x are receiving the root. But sometimes that gets a little confusing with handwriting. So what we do is we draw a radical that has what we call a hanging indent. And that tells us that if I have something like a 4 and an x, the x is the last thing that's a part of that. So if I had something else over here like a y, we notice that that hanging indent stops between the two variables. The y is not part of the root, the x is. And that's because sometimes it can be a little confusing if I were to write a 4xy and only root like that. Many people might say, well, the y is part of it. It's not part of it, and it's a little ambiguous, so we like to draw a hanging indent, and then it also helps to draw a little bit of a gap. But that's just background knowledge. Let's go ahead and let's begin. So I'm going to draw my line down the middle, and our first step is to isolate the radical. And so what I'm going to do is I'm going to go ahead and I'm going to circle our radical and ask, is there anything outside of the circle, anything outside of the radical on that side of the equation? Well, the answer is no. So we're going to move ahead and we're going to say, how do we get rid of a radical? Well, that comprises of a couple things that we've learned about earlier. We know to get rid of addition, we use subtraction. We know to get rid of multiplication, we use division, and vice versa. To get rid of the other, we use the first. And the last thing that we're going to be covering is to get rid of a power, we use a root, and vice versa. So in this case, my radical, or my root, I'm going to get rid of it by a power. So I ask myself, what root is this? It's a square root, so I use a square power. I'm going to square both the left and the right-hand side of the equation, which is going to give me this root and power cancel each other out, so I'm left with a 4x, and that 8 squared becomes a 64. And so we see the fact that simply by squaring the square root, it voids everything out and I'm left with a 4x. Don't fall into the mistake, and this is something that we do not want to do, is we don't want to double square. Oftentimes what students want to do is they want to square the 4 and make that a 16, they want to square the x, and they want to square the 8. This is not something that we want to do. We just want to get rid of the radical sign and rewrite what's left. So that way we can go about solving the equation like we always have by isolating the term and then isolating the variable. Let's see, 4 goes into 64 once, 24 6 times. So x is equal to 16. And so let's try one more. Now, again, while this is starting, I'm going to go ahead and I'm going to circle my radical. You don't need to do this because oftentimes just looking at it and seeing what's outside of it is helpful enough. But for those of you who are just beginning, I'm going to go ahead and add that extra element of color to help work things out. So I notice that there's nothing outside of my radical. So what I'm going to do is I'm going to go ahead and square both sides because I remember that a power and a root undo each other. And what that's going to give me is that's going to cancel out that radical and leave me with a 3h plus 12 is equal to 81. Remember, what we don't want to do is we don't want to square everything. We don't want to turn this into a 9h squared plus 144 is 81. This is not what we want to do. We want to simply remove the radical sign and copy this down. The 9 does not have a radical sign, so it gets squared. And then we go ahead and solve the equation by doing the same two steps we've always been doing, isolating the term, and then isolating the variable. And that's going to lead us to an h is equal to 23. Cool. So now what I want you to try is I want you to pause the video. I want you to try number 5 and resume it and see how you did. Okay, so let's take a look. I'm going to divide it, and I'm going to do this one last time. Circle my radical and say, is there anything outside? No. So I'm going to go ahead and square it to get rid of it. Leaves me with a 4y minus 16 is 144. Then I'm going to isolate my y term by getting rid of this 16, which means I need to do it over there as well. I have a 4y is equal to 160. Now that I've isolated my term, I'm going to isolate the variable by undoing that multiplication, which is going to be y equal 40. Perfect. And so now that we've seen how to undo a radical, let's see what happens when there's stuff outside the radical as well. And so in this case, when we circle it, we notice that there's something outside of the radical. I have a times 15. So my first step is I'm going to divide everything by 15, which is going to get rid of that 15, but not the radical. The radical is still there because all I did was I got rid of the 15. Which leads me to my next step, where now that the radical is isolated, there's nothing else on this side of the equation. I can now go ahead and square both sides, which this is going to give me 2x is equal to 900. We notice that a root and a power cancel each other out, so I'm left with just what's inside. This did not have a root, so therefore the entire thing got squared. And my last step is to divide by 2, so I get x equals 450. Perfect. Let's try one with a little more on the outside, not just something multiplied, but something added. And really, it's just as simple as, let's go ahead and get rid of the plus 10. Which is going to leave us to a 2 square root of h is 30. And then we get rid of the times 2, which is going to leave us with an h is equal to 15. And now that the radical is completely isolated, now we go through the step to remove it. And again, there are other ways to solve these equations. This is simply an algorithm of which I like to show because it's a consistent way to get to the answer. There may be a faster method out there, but this will consistently get you to the answer. And we get 225. So for the last one of today, again, I want you to try this one on your own. Go ahead and pause the video, give it a shot, and resume it to see if you got the same answer we did. Perfect. Let's try that out. So looking at my radical, I see that the plus 10 is on the outside, so I want to get rid of it. So I subtract 10 and it gets rid of it. So I have a 4y minus 16, all square rooted, is 12. Now that that's the only thing, I'm going to go ahead and cancel my radical by squaring it. So 4y minus 16 is equal to 144. Now there's no radical. It's a simple equation where I isolate the term. 4y is equal to 160, and then I isolate the variable. Perfect. So y is equal to 40. And there we go. So today what we're going to be covering is how to work an equation that has a fraction by doing what we call clearing a fraction. And this emphasizes a point that a fraction is really just division, but it's been paused. I'm saying x divided by 4, but I don't know what I'm dividing by 4, so I have to pause that operation and come back to it later. So a very quick and easy way that you're going to see later on when we cover systems is going to be clearing a fraction by just simply multiplying the entire equation by something that will void it. And so let's take a look at the first one. Now I see x divided by 4. We understand that division is undone by multiplication. And so how do we get rid of a divide by 4? Well, we're going to take the entire equation and we're going to multiply times 4. And I'm going to distribute this 4 into each one of these three terms, which means this 2 gets multiplied by 4, this x plus 4, or the x over 4 gets multiplied by 4, and this negative 1 gets multiplied by 4. Each one of these gets multiplied by 4. Just to make sure that that's multiplication. And so I left a little bit of room here because what we're going to do is we're going to notice that some of these are going to cancel out. First off, we know that 4 times 2 is going to give us an 8. We know that 4 times negative 1 is going to give us a negative 4. What we've done here is we've noticed that if we multiply by 4 and divide by 4, the 4s are going to cancel out. Because 4 divided by 4 is 1, I'm actually multiplying this x times 1, which is just going to give me a 1x. And so my next step would be, okay, cool. Let's go about subtracting my 8 from both sides, and that's going to cancel that one out. I'm left with 1x is equal to negative 12, or just x is equal to negative 12. That one coefficient, we don't need to write it. We know that our answer is this. And so some of you might be asking us, well, how does that cancel out? And the idea is based off of what we see over here. If I have a 4 times an x over 4, the first thing I need to do is I need to understand that that 4 has to be over a 1, which is going to lead us to the ability to rewrite this expression as 4 times x over 1 times 4. And then the next thing that we're going to do is we're going to swap the order. I'm going to say, well, 1 times 4 is the same thing as 4 times 1. Nothing changed, I just changed the order. So 4 times x. And what we notice is that what is 4 divided by 4? Well, 4 divided by 4 is 1. So that's going to be 1 over 1. And I'm not going to touch the x, and I'm not going to touch, that's a 1. It was almost an x, but. So I'm going to leave the x, and I'm going to leave the 1. But 4 over 4 reduces down to 1 over 1. That's the reduction. That's the canceling out. And then our next step is we're actually going to perform these operations. 1 times x is going to be 1x. 1 times 1 is going to be 1. 1x is actually just an x. X over 1 is just going to be x, which is what we ended up getting right here. So this is the long way. This is actually what we're doing when we say these cancel out. So let's try that one more time. If we see that we have a fraction with a denominator of 2, we know that is dividing by 2, and we get rid of that by multiplying by 2. So each one of these, the g minus 4 over 2 and the 10, both get multiplied by a 2. We know 2 times 10 is going to give us 20. And from what we just saw previously, if I have a times and divide by the same thing, they are going to cancel out, and I'm actually multiplying by a 1, which means this is going to be 1 times g minus 4, or just g minus 4. From that point, we add our 4, cancels out, I'm left with g equals 24. again, if this is a little confusing, let's work it out the long way. If I have a 2 times g minus 4 over 2, our first step is to put that 2 over a 1 so that we can combine numerator times numerator, so 2 times g minus 4 over 1 times 2. Next is I'm going to swap the order of these, and I'm going to say I have 2 times g minus 4 over 2 times 1. So all I did was switch the order. But this allows us to cancel out the 2's. So we're left with 1 over 1 is g minus 4 times 1. That's the canceling out. And with this next step, we actually multiply. So I'm going to distribute this 1, so I'm left with a g minus 4. 1 times 1 is 1. Anything over 1 is itself. And that's exactly what happened when I multiplied 2 and divided by 2, is I'm left with a g minus 4, which is exactly what we got when we worked it out the long way. So what I want you to do is, now knowing how the process is done, take a shot at number 5, pause the video, and resume it once you're done and see how well you did. Okay, so let's take a look. I see a divide by 4, so I know that the way to get rid of that is multiply by 4. I'm going to multiply all 3 terms by 4. I have a 1/4 x, I have a 5/4, and I have a 2. Each one of them is multiplied by 4. We know that these 4's cancel out, those 4's cancel out. Because those cancel out, I'm left with a 1x. Because those cancel out, I'm left with a 5. These did not, so I multiply and I get an 8. This allows me to subtract 5. To get rid of that 5, I have a 1x is equal to 3, or just x is equal to 3. So how'd you do? Well, let's try one more. Even a little more complicated. Instead of 2 fractions, let's try one with 3. So go ahead, try it again, pause the video, work ahead, and see how well you did. Okay, let's take a look. I see divide by 3, divide by 3, divide by 3. I know I undo division with multiplication. I'm going to multiply each one of these terms by 3. 1/3 x gets multiplied by 3. 2/3 gets multiplied by 3. And 7/3 gets multiplied by 3. We know that these 3's cancel out, those 3's cancel out, these 3's cancel out. So because those cancel out, I'm left with 1x. Because these cancel it out, I'm left with 2. Because these cancel it out, I'm left with 7. Which leaves me with a 2-step equation where I subtract 2. I'm left with 1x is equal to 5, or just x is equal to 5. Perfect. And so one of the questions you might ask is, okay, what happens if I have 2 fractions? Well, there's a couple ways to do it. The way we're going to do it today is we're going to clear all the fractions in one go. In the later lesson, we'll see what happens if we have fractions that don't all clear. Now, 6 and 3. 6 is a multiple of 3, so what we're going to do when I see fractions that are multiples of each other is I'm going to pick the biggest one, a 6. And I'm going to multiply everything in the equation by 6. I'm going to have 1/6 is multiplied by 6, 2/3 is multiplied by 6, and 2 is multiplied by 6. And so, real quick, what you notice is that 2 of these we know how to handle. 6 times 2 is going to give us a 12. We know that these 6's, like we've done previously,
are going to cancel out and leave me with a 1x. But what we haven't seen before is a 6 over a 3, which doesn't fully cancel out. This is what we call reducing. 6 divided by 3 is actually 2. So I'm going to multiply the numerator that's left over times 2, and that's going to give me a 4. And so let's take a quick pause, and I'm going to explain what just happened right here. So if I have a 6 times a 2/3, our first step is to make sure that 6 is understood to be over a 1, which allows us to rewrite it as 6 times 2 over 1 times 3. Our next step is to swap these two. So 6 times 2 over 3 times 1. And we're going to notice that 6 divided by 3 can reduce. 6 divided by 3 is 2, or in fractional form, 2 over 1. This 2 and this 1 stay the same. But even though it didn't cancel out, this is what we call reducing. Or we've reduced it. This allows us to actually say 2 times 2 is 4, 1 times 1 is 1, which is a 4, which is what happened right here. So we know that because we reduce this step and then finish working our fraction, if I see a 6 divided by a 3, I'm going to pause and I'm going to say 6 divided by 3 is 2. Multiply that top times 2. 4. That allows us to finish working the problem. And we'll get those 4's cancel out. And we're left with a 1x is equal to 8, which means that x is just equal to 8. Perfect. So now that you've seen that, try a shot at number 11. Go ahead, pause the video, resume it when you're done, and see how you did. Okay, so let's take a look. Just like before, I'm going to pick the biggest denominator, 10, and I'm going to distribute that to all 3 terms, which means this gets a 10, that gets a 10, and the last term gets a 10. Each one of them, the y over 5, the 3y over 10, and the 1/5. We know real quick that these 10s cancel out, and we're left with a negative 3y. And what we saw previously when we had a 6 over 3, that divided into a 2, so I doubled the top. Just like this, 10 divided by 5 is 2. I'm going to double this top. So double y is 2y. Look over here, 10 divided by 5 is 2. I'm going to double that top. So 2 times 1 gives me 2. And then at this, we just go about solving the equation. I'm going to combine those terms. That's going to give me a negative 1y. Next step is I'm going to get rid of that times negative 1 by dividing by negative 1, which is going to give me y is equal to negative 2. Perfect. And there we go.
So today what we're going to be doing is we're going to be clearing a fraction. And now this is an extension of what we've done previously. And this is going to be a crucial component later on when we do systems of equations using elimination. So I think it's important to handle now so we can get a good grasp on it so that it'll help us out later on. And there's 2 ways to do this. We can either take it one step at a time by clearing a single fraction each time, or we can multiply by the least common multiple of all denominators and clear them together, which is typically the way that we're going to do it today. So to start, what I'm going to do is say, what is the least common multiple between 10 and 5? And I know that the least common multiple is going to be 10, which means that each one of these is going to be multiplied by 10. So I'm going to multiply this by 10, 1/10 x. I'm going to multiply the 1/5 by 10 times 1/5. And I'm going to multiply the 1 by 10. And what this does is this is going to allow me to get rid of each set of fractions. And so when I look at this, I know that 10 divided by 10, when I work this out, 10 divided by 10 is going to give me a 1. So I'm actually only multiplying this 1x times 1. So 1x times 1 is going to give me a 1x. I'm going to move on to the next one. 10 divided by 5 is going to give me a 2. So I'm actually multiplying this number times 2. So 1 times 2 is going to give me 2. And then 10 times 1 is just going to give me a 10. And so what I've done, now I know I can solve this by moving the fractions around, but this has allowed me to eliminate the fractions and solve it, saving the division for the very end. So now what I can do is I can subtract my 2 from both sides, which is going to leave me with a 1x is equal to 8, or we can just say at this point x is equal to 8. Boom. And so this is how we multiply by the least common multiple. I could have gotten rid of the 5 and then gotten rid of the 10, but I like this method a little better because it's a little faster. So if I look at the next one, I see a least common multiple between 5 and 15 of 15. So I'm going to multiply each one of these things, 15, 15, and 15. Let's see if I got my spacing right. So 15 times 1/15 x, 15 times the 1/5, and then 15 times the 1. So each one of these gets multiplied by 15. And so I know that these 15s are going to cancel out. So 15 divided by 15 is 1. So 1 times 1x is going to give me 1x. And in this case, 15 divided by 5 is going to give me 3. So I'm going to say, okay, 3 times 1 is 3. In this case, 15 times 1 is 15. That allows me to solve the equation by adding this 3 to get rid of it over here. And I have a 1x is equal to 18, or I just know that x is equal to a regular old 18. Here we go. And so knowing that information, what I want you to do is I want you to pause the video real quick. And I want you to give a shot at number 5. And when you're done, unpause the video and see how you did. Okay, so let's see how we're doing. So my least common multiple between these, I could get rid of the 2's and then the 5's, but if I get rid of them at the same time, I know I'm going to multiply everything by 10, because 10 is divisible by both 2 and 5, so I know I'm going to get a bunch of whole numbers. So let's see if I can space this out. So I have 1 10, 2 10s, 3 10s, and 4 10s. That means each one of these 4 terms gets multiplied by 10. The 7 halves, the 1/5, the negative 1/2. I'm going to put that in parentheses just to make sure it doesn't look like we're subtracting. And the 61/5. So each one of these gets multiplied by 10. And so this 10 is going to divide by 2 and turn into a 5. So I'm going to multiply the 7 times 5 and get 35x. This 10 divides by 5 and turns into a 2. So I get a plus 2. This 10 divided by 2 turns into a 5. And so now 5 times negative 1 is going to give me a negative 5x. And this 10 divided by 5 is going to give me a 2. Which means 2 times 61 is going to give me 122. Cool. That allows me to solve this equation without any fractions. I'm just going to get rid of the x over here so all my x's are on one side. So I'm going to add 5x. That's gone. So I have 40x plus 2 is 122. I'm going to get rid of the constant over here by subtracting on both sides, which eliminates it. So I have 40x is 120. And my final step is I'm going to divide both of these by 40 to get rid of that coefficient. And so I get x is equal to 3. Perfect. Awesome. So now that you're really good at that, let's do one other example just to make sure we got the pattern down. So again, pause the video, give it a shot, unpause it when you're done. Okay, let's take a look. A multiple between 2 and 3 is going to be 6. And the idea is that I know 6 is divisible by both 3 and 2 and will give me a whole number. So I want to multiply everything by 6. I want to multiply this 3 halves by 6. I want to multiply this 35 thirds by 6. I want to multiply this negative 1/2 by 6. And I want to multiply this 25 thirds by 6. Each one of them I want to reduce. And so I'm going to go ahead and I'm going to reduce each one of these. 6 divided by 2 is 3. 6 divided by 3 is 2. 6 divided by 2 is 3. And 6 divided by 3 is 2. So really all I'm doing is I'm multiplying this top term by this. So 3x times 3 is going to give me a 9x. 35 times 2 is going to give me a 70. Negative 1 times 3 is going to give me a negative 3. 25 times 2 is going to give me a 50. And this is going to allow me to isolate my variables. Getting rid of the 1 on the right goes away. I get 12x minus 70 is 50. Get rid of my numbers on the left, so I'm going to get rid of this negative 70. In essence, I'm moving it over. So I get 12x is 120. And then to get rid of that coefficient, dividing by 12, I'm looking at the 120 while I'm writing. And so I know that x, 12 fits into 120 10 times. So how'd you do? What? So these weren't too bad. I only had 2 variables to consider, or 2 denominators to consider. What happens if I have 3 different denominators? What happens if I have a 3, a 5, and a 15? Well, today isn't going to be too bad, because what looks like is going on is that a multiple between 3 and 5 is 15. So I'm going to multiply everything by 15. I'm going to multiply this 2 15ths. I'm going to multiply this 2 fifths and this 4 thirds. I'm going to see what happens. I know this reduces down to a 1, so I'm only multiplying by 1. This is going to reduce down to a 3, so I'm only multiplying by 3. And this is going to reduce down to a 5, so I'm only multiplying by 5. And we see that it's no different than one of the ones before. The only thing is I'm multiplying each term by something different, because each fraction reduced to some different number. So 1 by 2 is going to give me a 2x. 3 by 2 is going to give me a 6. 5 by 4 is going to give me a 20. I'm going to get rid of the number over here because my variables are already together. So I get 2x is equal to 14. To get rid of that coefficient, I'm going to divide. So x is equal to 7. Perfect. So what I want you to do is I want you to pause the video. I want you to give a shot at number 11 and unpause it when you're done. Okay, let's give it a shot. So just like before, I'm going to pick a multiple of 3, 11, and 33, which we know a multiple of all 3 of those numbers is going to be 33. So multiplying each term times 33. I think I might have spaced these out a little too much, but regardless, I'm multiplying this 4 33rds x times 33. I'm multiplying this 4 11ths times 33, and I'm multiplying this 4 thirds times 33, each one of them. And so each one of these reduced down to 1, reduced to 3, and reduced to 11. So what that's going to do, 1 times 4x is 4x, 3 times 4 is 12, 11 times 4 is 44. And that's going to allow me again to get rid of my numbers on the left. They go away. I only have my variable term, that turns into a 56. And then when I only have my variable term, I can divide away the coefficient, which is going to give me an x is equal to, let's see, 1 left over, 4. There we go. And that's it. So today we're going to be solving equations that are empty sets and identities. And the idea behind this is that most of our answers up until this point have been what we call conditional statements, meaning the answer is sometimes true and has a limited number of solutions. 9 times out of 10, you're going to get something like x is equal to 7. The only answer that works is if I plug in 7 for x. If I tried to plug in 8, 8 does not equal 7. So that's extremely limited. Other answers are like, let's say x is less than 10. This has more answers. In fact, it's actually infinitely large, but it's limited because some of them I cannot plug in. If I said 0, if I said -1, if I said -100, if I said 9.9, those would all work. Those would all be true. But if I tried to plug in 11, it wouldn't work. So I'd have to say that the equation is sometimes true, or the statement, I should say. What we're going to see today is the other two cases, an empty set, where we might end up with something like 5 equals 6. And so the idea is no matter what I plug in, 5 will not equal 6. If I try and plug in a 7 for x, well, no, it doesn't matter. 5 still doesn't equal 6. So I usually draw a slash to that. And the flip side is we might end up with an identity. If I get something like 5 equals 5, doesn't matter what we do, this is always true. No matter what, if I try and say x equals 7, 5 still equals 5. If I say x equals 11, 5 still equals 5. If I say x equals pizza, 5 still equals 5. It doesn't change. So today we're going to see either something that's always true or something that's never true. So let's go ahead and take a look. Now, these equations, when we start out, aren't going to look too different than anything else we see. I see an equation, I see parentheses, so I'm always going to start out by saying, hey, let's get rid of the parentheses. There we go. Pen took a second to start working. So 2 times 5x is a 10x, plus 8 is 10x plus 6. And many times students just stop at this step, but let's not forget, we do need to actually eliminate the variables, which means I need to get rid of the 10x. And I end up with a statement that has no variables, has no ability to change. I just get 8 equals 6. That does not work. So my answer for this is going to be false. And then generally speaking, you're going to write, in addition to that, you're going to write one of 3 things. You're either going to write empty set, or you're going to write no solutions, or sometimes you'll write the empty set symbol. As long as you write that this statement is false and give one of these 3 things, you're good. So let's try another one. Again, these look unassuming at first. It looks like just a regular old equation that you're going to solve. So we would distribute. 11 plus 2x is 2x plus 8 plus 3. I notice that I can get rid of my x on both sides, and I have 11 equals 8 plus 3, in which case I'll reduce that down to 11 equals 11. This time, unlike before, 8 won't equal 6. 11 always equals 11. I know I have a true statement. No matter what I plug in for x, my x's will be removed. If I say x equals 100, well, then I'm going to subtract it from both sides. So for a true statement, you either write one of 3 things. You either write identity, you write infinite solutions, or you write the infinity symbol. One of those 3 things. And so we see the fact that it's really not a big deal. It just looks a little different, and most people freak out when they see, oh my gosh, I completely eliminated my variables. Not a big deal. So let's try something a little more advanced. With something like this, I see that I have fractions. So generally speaking, I like to get rid of the fractions. I'm going to multiply a 6 throughout each one of these, I know that if I say, okay, so 6 times 6 times 6 times 8 over 3 gets multiplied, 4/3 gets multiplied, and this 8/6 gets multiplied. 2 plus x. However, we know that the 2 plus x does not get multiplied because I don't double distribute. I don't go inside a set of parentheses. I only go inside once. I know that 6 divided by 3 reduces down to 2. 6 divided by 3 reduces down to 2. 6 divided by 6 reduces down to 1. So I'm going to multiply 2 times 8 and get 16. 2 times 4 and get 8. 1 times 8 and get 8. 2 plus x. Boom. So I'm dealing with something a little more easily handled. I'm going to go ahead and distribute my 8 there. So I have 16 plus 8x is equal to 16 plus 8x. Okay. And then as I continue forward, my last step is I'm going to get rid of an 8x on one of the sides. And they both cancel out, so I'm left with a statement where 16 is equal to 16. We know this is true, so it's either an identity, it's either infinite solutions, or we draw the infinity symbol. Perfect. So on these last two, what I want you to do is I want you to pause, see if you can knock out these last two, see what you get, resume the video once you're done. Okay, let's take a look at how we're doing. So the first thing that I see is I notice that I have a set of parentheses and I have fractions. So I can either get rid of the fractions first or I can get rid of the parentheses. And either way you like to do it, it really won't matter the difference. I can't get rid of the fractions first because I can't double distribute, so I'll still have that protected inside this. So I'm going to go ahead and get rid of the parentheses first. That'll allow me to, if I need to, get rid of the fractions in one fell swoop. So I have a 5/3 x minus x is 1/3 plus 2/3 x. So now, if you want, I can go ahead and I can clear my fraction by multiplying everything by 3. I know that 3 divided by 3, I'm going to skip writing this step because at this point, I'm just reducing everything. So 3 divided by 3 is going to give me a 1. 1 times 5 is just 5x. 3 times x is 3x. This reduces, so 3 divided by 3 is 1 times 1. 3 divided by 3 is 1 times 2. Boom. My next step right there is I'm going to combine these two terms. So I have a 2x equals 1 plus 2x. My final step of subtracting the 2x cancels out on both sides. I have nothing left on the left. I have 1 left on the right. I know that 0 does not equal 1, so I get a false statement. So I know my answer is either empty set, no solutions, or the empty set symbol. Perfect. And then as we tried number 9, you might have had a little more luck with these fractions because as I got rid of the parentheses first, I noticed that most of them just canceled themselves out. So 7 over 7 is going to give me a nice natural 5. That reduces down, so I keep my top. That doesn't, so 7x. Then what I get is 7, And over here, I can say, okay, half of 10 is 5. Half of 4x is 2x. No fractions. I didn't need to clear anything. So I have a 5 plus 2x equals 5 plus 2x. If I go ahead and subtract the 2x's, they go away. and I'm left with a statement of 5 equals 5, which I know for this case to be true and always true. So it's either an identity, infinite solutions, or I just draw the infinity symbol. So true statement in one of those three things, and you're good to go.